Well, hello, this is Mrs. Robertson, and today in Math 6, we are going to do Chapter 7, Lesson 2 on page 587. Excuse me, it's Chapter 8, not Chapter 7. Chapter 8, Lesson 2, Function Rules. And this is on page 587. Let's look at some of our new vocabulary words that we have here today. It says, a sequence is a list of numbers in a specific order. Each number in the list is called a term of the sequence. So each number will be referred to as a term. Arithmetic sequences can be found by adding the same number to the previous term. In a geometric sequence, each term is found by multiplying the previous term by the same number. All right, so now it has us comparing different terms or sequences. Compare arithmetic sequences and geometric sequences. Okay, so what they want us to do here is talk about how they're alike and different. So in the book, the definition of an arithmetic sequence is, let's write this down, a sequence, everyone's pencils should be moving, which the difference between any two, I'm just going to put the difference instead of which, the difference, Alex, I don't see your pencil moving, between any two consecutive, between two consecutive terms. Now, does anyone know what the word consecutive means? This is important in this definition. It means they're side by side, consecutive terms. In numbers, 1, 2, 3 are consecutive because they're right beside each other. 5, 6, 7 are consecutive numbers, so they're right beside each other. That's what the word consecutive means. Terms is the same. So 1, 2, 3 would be an example. They're all one apart. Another example, let's say 3, 6, 9. They are consecutive numbers. We are counting by what? Threes. Do you get it? So those are consecutive numbers when counting by threes. Any questions? Alex, do you have that all written down? Great. Can you show me your paper? Yeah, just sit down here so I can make sure I'm not going too fast. Now we're going to do geometric terms or sequences. Nice. In geometric sequences, a sequence each term, a sequence where each term is found by multiplying the previous term by the same number. The previous term by the same number. They don't really make these boxes big enough. All right, let's say I'm going to go by fours. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. 4 times 4 is 16. Any questions? I I'm thinking, is that correct for that definition? Okay. Now let's go on and look at the real world link. The China Palace sells lunch specials for $6 with a delivery charge of $5 per order. Fill in the table with the next three numbers in the sequence. Okay, so one lunch special, so it's 6 plus 5 equals 11. Here, 2 times 6 is 12, so 12 plus 5 is 17. Do you see what they're doing? In this one, 3 times 6 is what? 18 plus 5 gives them the 23. 4 lunches, 4 times 6 is 24, plus the $5 delivery gives them 29. Do you see the pattern? So, if you're getting 5 lunches, 5 times 6 is what? 30. Plus the delivery, what's the answer going to be? 35. 6 times 6 is 36, plus 5 is 41. Now, do you see a pattern down here if you didn't want to have to multiply by 6 and add 5? What's the difference in between each one of these answers? Yes. That's right. It increases by 6. So what's the answer to this one? 47. 7 times 6 is 42, plus 5 is 47. Any questions on that? Got that one all filled out? Okay, let's go to page 588. Arithmetic and geometric sequences. Determine if a sequence is arithmetic or geometric can help you find the pattern. When you know the pattern, you can continue the sequence to find missing terms. All right, so let's look at example number 1. Describe the relationship between the terms in the arithmetic sequence. Then write the next 3 terms. Well, they figured out between, it's plus 7, right, between each one. So the next 3 terms, 28 plus 7 is going to be 35. What's 35 plus 7? 42. And 42 plus 7? All right, any questions on that arithmetic sequence? Let's go to number 2. Here, describe the relationship between the terms in the geometric. This is a geometric one because they're multiplying. Then write the next 3 terms. Here, you are multiplying each one by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. What's 16 times 2? 32. What's 32 times 2? And 64 times 2? That's right. Any questions? Okay. Now it says, do these problems to find out. Well, it doesn't say what they really want you to do in those, does it? I guess it wants you to determine the next 3 terms. Okay, so what are the next 3 terms? So find the next 3 terms here for each one. Go ahead and do that, and then we'll check your answers.